So in this section, we are going to look at the problem 32nd problem in Project Euler. Okay, so let's see the question. We shall say that an n-digit number is Pandigital if it makes use of all digits 1 to n exactly once. For example, the 5-digit number 15234 is 1 through 5 Pandigital. So the product 7,200 is unusual as the identity 39 times 6, 7,000 containing multiplier, and the product is 1 through 9 Pandigital. So as you can see from this equation, all numbers are not duplicated. So, and this is not 1 through 9 Pandigital, this is 1 to 8 because there's no 9. So that might be some problem in the problem. So find the sum of all products whose multiple, multiplier, and product identity that can be written as 1 through 9 Pandigital. Some product can be obtained in more than one way, so be sure to include it once in your sum. Okay, so for this question, right, we have to know that that would be 9 numbers here because it needs 1 to 9 Pandigital. So let's say I have something like this. Times. Okay, so this is the maximum number that we need to find because 4 digits times 2 digits to 5 digits. So actually, in fact, this is way over the limits. That's really good. Yeah. We just do this, something like this. Okay. So this is the algorithm that I'm going to use. So for 4 digits, the maximum that we can go is okay. And for here, the maximum digits that we can go is 4. So equals to, but as you know, by multiplying such digits, you will get the value that is over 5 digits, 6 digits here. Anyway, I just don't care, I just will force it. So from, okay, let's see my solution right here. So for int equals to 1 and I less than 9,876, and this is basically a brute force. I look this and look this and try to identify whether both the 3 numbers are Pandigital or not. So this is the first number, multiplicand. This is here and the multiplier here. So this is a multiplicand. We check for the uniqueness because 4 times 3 equals to 3 times 4. So make sure we check for it. And also we need to check whether the number is Pandigital or not. If the number is Pandigital, then we proceed. Otherwise, we ignore it because this is not going to form the solution or we will not get what the question wants. So this is a second loop multiplier. So we check for the uniqueness, because let's say is for this, right? If we found 12 here, then we are not going to do that again. This filter is to make sure that we satisfy this. Some products can be obtained in more than one way. So 12 can be obtained in more than one way, either 4 times 3 or 3 times 4. So we only take one case into account. So next, we add the sum. We add the product to the sum, and then we display the answer. So okay, for this check unique function, we'll see. So this is basically to check whether the number in the digits in the number do duplicate or not. So initially, I start a Boolean array. If I found the answer is something like this, okay. So for the first row, I extract the 5. So I put the 5. I mark the 5 as true. So initially the Boolean was false. And next loop, true. And next loop, true. And next loop. And from here, we found that the value in the array with index of 5 is already true. So this is not Pandigital. So we ignore this. So this function is basically for you to check whether the number is Pandigital or the number in the digits in the number is unique or not. If the number is not unique, which means that it's something like this. So it will ignore this number because it won't form the solution. So if something like this, okay, that it will pass a test, because basically, yeah, this function is a check test. Okay, next, what is this function? So this function does checking too, but this is to filter through the numbers. This is to combine the numbers so that, let's say we have this number. Equals to something. So this function is to combine the numbers up and check whether the number is Pandigital or not by combining this is for checking 3 numbers. The numbers previously that I talked about is to check one number, but this is to check 3 numbers so that every number in the combination is unique. So this is the number. If this is unique, then we add the count. This count, it does not exist here because I don't have to check for the Pandigital status of it. Let's say 1 to 3, 3 to 4 Pandigital. I don't have to care about it because I just want the number to have no duplicated digits in it. And for here, we need to check whether it is how many Pandigital flag, which is the array, which is array here. To choose, then we add a count to it to identify the number is Pandigital from 1 to 9. So in the end, I will return the count equals to 9. So if this is if the combination of 3 numbers are in Pandigital, so the count should be 9. as the question wants the status as 1 to 9 for the combination. So if you have other combinations like 1 to 3 or 3 to 5, then this won't works. You need different style, because let's say, right, 1 to 3, it's 1 to 3, 4 to 6. For this case, if you use count, you can't differentiate whether it's 1 to 3 Pandigital or 4 to 6 Pandigital. So you need to modify the code a bit. But for this case, it is fine because it looks through from 1 to 9. 1 to 9. So there's no other combinations that you can get from here. So this is basically a brute force. So perhaps we can show the combination that we have here. I2. Well, let me show you. Okay. So these are a combination that we have. See? See? Okay. This is 1 to 9 pen. So these are the solutions for 1 to 9 Pandigitals. So the sum of them are 45,228. And yes, this is the answer, same with the answer, the official answer given by Project Euler. So yeah, this is about this question, quite a simple question. You can just use your brute force to solve it. But my solution is quite slow. But that's fine because Project Euler gives 1 minute of limit, but this only takes 232 milliseconds, which is 0.2 seconds, which is just fine, much lower than the limits given. Okay, so yeah. So this is it. So this is problem 22 in Project Euler. This is a solution. So you can find the solution on GitHub if you want. So the link is provided in the description. So yeah, see you next week. Bye bye.